A skateboarder rides down a hill. She starts from rest and reaches the bottom of the hill in 5 seconds. When she gets to the bottom of the hill, she is moving 10 meters per second. What was her acceleration? And like all good physics problems, I like to start with a little bit of a drawing. And here's a little shout out for David Sledge, Danny, and Kate. I always see them drawing, and they give me some great drawings when they turn in the work. So this is my effort to give back to you guys. So let's say we have this little hill over here, and we'll give it a nice even grade or slope. And let's try to draw. There's a skateboard there and a little stick person here. It's close. I'm trying, guys. And then let's call this right here the start, since this is at the top of the hill. And then let's call this line down here, let's call that the finish, or the bottom of the hill. And let's remember, let's look at our formula for acceleration. So the formula, as if you can remember, the formula for acceleration is going to be the change in velocity, and that's what this little triangle is. It's called a delta, and whenever you see a delta, it's just the change. Don't let that confuse you. And the change of velocity over the change in time. So again, acceleration, this is what we call acceleration. We just write it as an A, equals the change in velocity divided by the change in time. And another way to write this is just to write it as the final velocity minus the initial velocity divided by the final time minus the initial time. So we're going to go through here. One of the toughest parts of this problem is simply just identifying what our numbers are. So let's look at this final velocity here. So the final velocity, that's going to be the velocity as at the finish, when you're what you're left with after the acceleration has been put on you. So in this problem, they tell us when she goes to the bottom of the hill, she's moving 10 meters per second. So that's going to be our final velocity. Let's think about our initial velocity. Our initial velocity is simply what are we moving when at the start. So in this problem, she starts from rest. So if she's starting from rest here, go back. If she's starting from rest, that's going to be a velocity of 0 meters per second. If you're not moving, you're moving 0 meters per second. Let's also try to find these times here. So if we're saying that the time at the start, let's just call it 0, just because, you know, it'll land us nicely in the end. And let's say that the time that we finish with is going to be just 5 seconds, because she starts from rest and reaches the bottom of the hill in 5 seconds. So we're going to call this our final velocity, or final time, excuse me. So now that we've identified everything, let's just go ahead and plug the numbers in here. The final velocity, which we decided was going to be 10 meters per second, so go ahead and write that down. Remember to include your units. And then our initial velocity, since it started from rest, as the problem states up here, it starts from rest, we're going to just go ahead and call that 0. So we're going to subtract 0 meters per second. And then the total time, the final time we decided is at the bottom of the hill. It was moving 5 meters per second. So that's going to be our final velocity, or our final time. And that's going to be, just go ahead and write that as 5 seconds. And then our initial time, since it started from rest, and it just makes it convenient if we were to just call this point right here, we're just going to start the stopwatch at time equals 0. So we're going to go ahead and put a 0 seconds here. So it's just a simple math problem from there. So 10 meters per second minus 0 meters per second, we're going to be left with a 10 meters per second. 5 minus 0 is going to be 5 seconds. Excuse me, I'm getting confused there. It's just going to be 5 seconds, and then it's just a division problem from there. So 10 divided by 5 is going to give us a positive 2 meters per second, and then that's per second, since you have meters per second divided by a second. So what this problem is telling you is that every second, which is down here, you're getting 2 meters per second faster. So every second I go, I'm getting 2 meters per second faster. And we don't usually write the problem like this. We usually write it, if this is the same thing as just writing it as 2 meters per second, and then we're going to square the seconds. Those things are the exact same, but it's super important that you understand what this is actually saying. And then also at the end, you want to check, hey, is it a positive or is it a negative acceleration? Because that's how you can check if you got it right. So in this problem, he's starting from rest and he's going down this hill. And he's speeding up. Since he started from rest, he ends at 10 meters per second. So in this problem, he should be accelerating, which is a positive acceleration. So if we look at our answer here, we get a positive 2 meters per second squared. So if we would have done this problem and let's say he was slowing down, we should expect to see a negative acceleration. But since he's speeding up, he's going down this hill and he starts from 0 and he ends at 10 meters per second, he's got to have a positive acceleration. Since he's speeding up, it's a positive acceleration. So we know, or we have a good idea that our problem is, we probably did the problem right if we get the right sign here. So just a couple tips, and all the acceleration problems are pretty much the same. So if you have any questions after this, just go ahead and feel free to ask me.